In lesson 4, we talked about cylinders, and this one we're going to talk about the surface area of a cone. Oh, sugar plum. Hopefully you weren't paying any attention. So if you take a cone apart, and this was always a little bit mind-numbing for me, because I thought, oh, it's a triangle, it's a this, it's a that. What would it make? Again, we're going to take it apart, and we're going to lay it down flat. Oh, the easy part, yeah, it's got a circle on the bottom, right? So that's the easy part. It's got a circle. But what about this curved surface that comes to a vertex? What's that going to look like when I straighten it out? And you have to, use your imagination and pretend that this is perfect. It is pretty good considering I did it myself. Okay, so I take that off. If I cut it up the side and I'm going to tear it. Sorry. Oh, no. There we go. There we go. If I cut it up the side and lay it down flat, take a look at what I have. It's actually a part of a circle from the center out. Now, I had a lot of people say, well, it's always at 1/3 of the circle. It's always 1/2 of the circle. It's always, just this. But you have to understand that depending on the size of the cone will change what the sector, that's what it's called, the sector of a circle, because it's from the center, goes out on 2 radii, and it gives you a piece of the pie, if you will. So take a look at this one. This one's kind of tall and skinny. I cut it from the same circle, but see how the difference between this cone and this cone? This one's a little fatter, this one's a little skinnier, and look at the difference of the sector of its circle. This one is only a smaller portion of the circle, where that one, even though they didn't look that much different, when you had it, yeah, that one was skinnier, but look at how much bigger a part of the circle it is. So it is a sector, it's a piece of a circle. So because of that, our formula actually has not 1, but 2 pies. All right, we have this one right here, which is going to be pi r squared, okay, because that is the radius of your base, okay? But this one, this piece is another circle. However, the radius of this circle is not the same radius as the bottom of the cone. It's actually, the radius of this sector is the slant height of your cone, if you remember talking about that. I know I mentioned it. So your formula is going to be, again, 2 pieces. So the lateral area is pi times r times slant height. They use a cursive L for slant height, and I strongly suggest when you put your formula, you use a cursive L as well, so that it doesn't look like a 1 or an I or something different. Okay, so slant height, that is the lateral area just for that. Then if you want to find the total area, you're going to add that pi r squared on the bottom. Okay, so your overall formula, actually we do find a little bit. Let's just find the lateral area here. Okay, so the lateral area down here on slide number 3, find the lateral area of a cone with a radius of 4 and a slant height. Well, the lateral area is pi times radius times slant height. So pi times 4 times 9.5. Well, again, I'm going to have you give me the exact answer. So first, just taking 4 times 9.5, which should come out nicely. It's 38 pi, and then the approximate answer, after you multiply by pi and round, you get 119.4. And inches, right, squared, again, still an area, okay? So inches squared, we have a 2-dimensional left, right, up, down, so area is 2-dimension squared units. Find the lateral area of a cone with a diameter of 16, so a radius of 8, and a slant height of 10, so pi times 8 times 10. Well, that's pretty simple. That's 80 pi, and I just have to take 80 times pi here, and we get approximately 251.3 inches. Oops, nope, this one's centimeters squared. Okay, now if you want to find the total surface area, obviously you got to add that circle from the bottom. So that's where this comes from. Pi r squared plus pi rl. Again, it kind of rolls off your tongue. Pi r squared plus pi rl. So our surface area for a cone, pi r squared, our circle, plus pi r l. And there we go. What is it? Pi times 4.5 squared plus pi times 4.5 times 20. Okay, so this one's going to be 90 pi. I could do that one in my head. The 4.5 squared, that's a little trickier. But that is 20.25 pi. Add them up. So 20.25 plus 90 is going to give me 110.25 pi. And then approximately, when I multiply by pi and round, 346.4 millimeters squared. There you have it. It looks a little blurry. Let's see if I can make it any clearer. Oh, that's a little better. Good. So let's talk about this. Ralph has a party hat. Well, the party hat looks very similar to something like this, right? But I don't know if you guys are, wear a lot of party hats, but I'm pretty sure if there's a circle covering this base, it wouldn't fit on your head, right? So the party hat really is just lateral area, and then it even says lateral area. But hey, be careful, because this is a great quiz and test question. If you're talking about a party hat made of paper or made of something in the shape of a cone, you're not going to include the base. All right, so the diameter is 8, which means the radius is 4. So we have pi times 4 times 11, and that's it. No circle. So we got 44 pi, which is approximately, get out my handy dandy calculator, 138.2 and inches squared. Okay, we're going to continue to go through this. Again, just like the cylinder, I'm going to require that you give me an exact answer and an approximated answer. But more importantly, in these, I will require both lateral area and surface area. Oh, I didn't talk about that, did I? Okay. All right, never mind that. So lateral area and total surface area. Right here, this is pi times 12 times 18. So 12 times 18 is 216 pi. And to that, I'm going to add the pi times 12 squared, or plus 144 pi. So 216 plus 144 pi, I get 360 pi, which is approximately 31.0 feet squared. Okay, now the next one, 30 is my diameter, so my radius is 15. Gosh, some big numbers here, right? Okay, so we have pi times 15 times 6. So 15 times 6 is going to be 90. So we got 90 pi for our lateral area, plus our pi times 15 squared. Guess what? That's 225 pi. Yeah, I do know that in my head. Okay, so when I add those two up, 225 plus 90 gives me 315 pi, which is approximately 989.6 meters squared. So this is your questions. This is what I expect to see. On your homework assignment, I will tell you that I know it says lateral area, but I just want the total surface area. So if I can see that you have a lateral and the circle and the lateral area, that's what I'm happy about. I want you to understand that makes a difference, okay? Down here, read those word problems carefully because it's lateral area, and then on the back, oh, there's a hat problem, and yep, most of these on the back are going to be lateral area, so be careful, be careful. All right, so I'm going to skip over this word problem because I think you can handle it. I know you got fractions in there, but we got calculators that handle fractions, right? This last one, though, identify the ones that go together. So All right, well, here's a sphere, and so the only one that has a cubed radius has got to be that one, right? Oops, just kidding, and this one, because it's half of it. All right, then a cone, we need the pi RL plus pi r squared is that one, and then two circles. Ooh, you know what? That's not even the right surface area, is it? This one should have a 2 here because it doesn't have the 2 for the pi r squared, 2 circles. So I don't know if you caught that, but I did. All right. You have a blue worksheet. If you have any questions, come and see me, but I think you guys should be good as gold. All right, good luck.